Assalamualaikum. My name is Muhammad Shahrizan bin Umar. Today, we want to share with you guys about Euler's theorem for Axially load columns. Firstly, Euler's theorem for Axially load column is fundamental concept in structural engineering that describe the behavior of slender column subject to axial compressive loads. Its theoretical principle formulated by Leonhard Euler, a renowned mathematician and physicist. When a column experiences an axial load, it might buckle or deform under the applied force. Euler's theorem provides a critical formula to determine the critical load at which buckles across. This theorem establishes a relationship between the applied load, the column's material properties, and its geometry. The formula derived from Euler's theorem for an axially load column helps engineers determine the critical buckling loads. This information is crucial in designing structures to ensure they can withstand the compressive force without failing due to buckling. Actually, what is axially load column? An axially load column is a structural element typically found in engineering and construction, designed to primarily support axial vertical loads such as compression or tension force along its longitudinal axis. These columns are often slender, elongate, and usually vertical members within a structure, such as those in buildings, bridges, or industrial frameworks. The key characteristic of an axially load column is that the primary force it experiences are predominantly along its length, either in compression, pushing force, or tension, pulling force. These loads act parallel to the longitudinal axis of the column. In structural engineering, columns play a vital role in supporting the weight of structures and transferring loads to the foundation. Understanding how axially load columns respond to applied force, including their ability to withstand compressive loads without buckling or failing, is essential in designing safe and efficient structures. Euler's theorem for axially load columns provides a theoretical framework to predict the critical load at which buckling, a form of structural instability, might occur in such columns when subject to compressive force. This theorem aids engineers in designing columns capable of safely bearing applied loads without fail.
Hi, my name is Fitri Nizam. Today I will explain to you about design factor of the Euler theorem. Factor of safety. Engineer add a safety margin to the calculate critical buckling load. This extra factor ensures the structure can handle load well above the calculate critical load. Consider unchanged material properties. Choosing material with no properties like elasticity and strength is curious. This ensures the column can be handled expected load without going beyond safe stress limit. Geometry parameter. The dimension of the column, such as a length and shape, matter. Design the column geometry properly ensure it can resist buckling under the applied load. And support condition. When both ends are pinned, the effective length is typically the same as the actual length. This, along with free rotation at both ends, influence the design consideration for stability. Load type and application. Knowing the type and amount of the expected load help design structure capable of handling them without failing or buckling. Considering this factor ensure the creation of the strong and safe structure, especially taking into the account a scenario where both and the column are pinned. Euler theorem for axial load column.
Hi, Assalamualaikum. My name is Nur Faranim. Today, I will explain to you guys about effective length of column based on Euler's theorem, both and pin inches. Euler's theorem for axially loaded is a crucial concept in structural engineering. It helps us understand how slender columns behave under pressure, predicting when they might buckle or fail. This knowledge is essential for designing strong and resilient structure. Euler's theorem establishes a connection between the applied force, the column material properties, and its shape. This relationship is practical, guiding engineers in creating safe and durable structure that can withstand significant pressure without collapsing due to buckling. When both ends of a column are pinned in Euler's theorem for axially loaded column, effective length is simply the actual length of the column. This is because the pin end allow free rotation and there is no restriction on the column movement at the support. Or, in practical terms, you can consider the effective length to be the same as the physical length when both ends are pinned.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Fardan Hakimi bin Fauzi. Today I want to share with you about calculation for Euler Buckley formula for post and pin. So let's go. Calculation for both and pin. Steel column pin at both ends has a modulus of elasticity 2 times 10 power 5 Newton per square millimeter. Moment of inertia 9 times 10 power 4 millimeter power 4. Length 1.75 meter. Value of Euler's critical load will be given. Modulus of elasticity 2 times 10 power 5 Newton per square millimeter. Moment of inertia 9 times 10 power 4 millimeter power 4. Length of the column 1.75 meter. We will use Euler buckling formula for both and pin. Pi power of 2 times modulus of elasticity times moment of inertia divided by length of the column power of 2. Plug in the value into Euler's formula. Pi power of 2 times 2 times 10 power of 5 Newton per square millimeter times 9 times 10 power of 4 millimeter power of 4 divided by 1.75 meter power of 2. Let's calculate this. Pi power of 2 times 2 times 10 power of 5 Newton per square millimeter times 9 times 10 power of 4 millimeter power of 4 divided by 1.75 meter times 1000 power of 2. We must convert unit of length from meter to millimeter. Pi power of 2 times 2 times 10 power of 5 Newton per square millimeter times 9 times 10 power of 4 millimeter power of 4 divided by 1750 millimeter power of 2. The answer is 58,009.1 Newton.
Hi, I am Nurul Faezah.
The conclusion we can conclude for Euler's theorem for axial loaded column both end pin is, if a beam element is under a compressive load and its length if the order of magnitude are larger than either of its other dimensions such as beam is called a column. Due to its size, its axial displacement is going to be very small compared to its lateral deflection called buckling. Quite often the buckling of column can lead to the sudden and dramatic failure. As a result, special attention must be given to design of column so that they can safely support the load.
Euler's theory of columns states that a column behaves to resist buckling. He stated that the end condition of the column and flexural rigidity influence buckling. Therefore, Euler's theory of column can be used to calculate the buckling load of the column. The advantages using Euler's method is that it can be used to solve many nonlinear differential equations as well as linear differential equations. In summary, Euler's theorem for axial loaded column with board and pin is a basic formula to estimate when a slender column might buckle under compression. Here are the key takeaways. First is formula. The critical buckling load P is given by a simple formula involving the modulus of elasticity E, moment of inertia I, and effective length L. Second is effective length. For board and pin, the effective length L is just the actual length of the column. 3 is effective length factor. K for board and pin, A is 10. So here the design tip: choosing stronger materials E and optimizing the column shape I can increase the critical load. Properly designing end condition affect the effective length and critical load of the column. 5 is limitation. The theorem is a simplified model and may not be accurate for short and heavily loaded columns. In practice, engineers use Euler theorems cautiously, understanding its limit and often combining it with other methods for precise and safe structural design.